Hey, what's going on guys? In this video we are going to see how to find the operating mode of a BJT. Here the question is asking find the region of operation for the BJT and find terminal currents and voltages. There are two methods you can use. One method is you can assume this BJT is in active mode and then you can solve for this one. Or you can assume this is in saturation mode and solve for this one. If you watch my previous video, I have shown that how to do this one using assuming this circuit is in active mode. Here we are going to see how to do this problem assuming this circuit is in saturation mode. Okay, now in order to be saturation, VB has to be 0.8 and VC has to be 0.2. so this is the condition for saturation. And also if assuming this one, if we get a beta minimum value which can be calculated using this formula, beta minimum, or we can say beta forced, because we are forcefully assuming this is in saturation, so we can also call this one beta forced. That should be equal to IC over IB. I mean, that can be calculated using IC over IB. And if we calculate this one and if we find out that this value is less than beta, the given beta 100, this is in saturation, otherwise this is in active mode. Okay, now let's go ahead and figure that one out. Since we know that VBE has to be 0.8, and here you know that wherever we have arrow, that's the emitter E, and this is base and this is the collector, right? So this is the VC and this is VC and this is VE and this is VB. Okay, from this one you can see this, since this is connected to the ground, VE is equal to 0, then VBE mean VB minus VE. Since VE is 0, VB has to be 0.8. so this voltage is 0.8 voltage and this one is 0.2 voltage, because VC minus VE is equal to 0.2 voltage. VE is 0, therefore VC must be 0.2 voltage. So now we found out VB and VC. The next thing is we have to find out what is the IC and IB. Now to find out the IC, you can simply use this formula. VC is equal to VCC minus IC times RC. And if you rearrange this one, this is going to become ICRC. That's equal to VCC minus VC. Therefore IC is going to be VCC minus VC divided by RC. Okay, VCC is what, this one, 8 voltage, VC 0.2 divided by RC, that's 1K. So we are going to get 7.8 divided by 1K, that's going to be 7.8 milliampere. This is our IC value. Now the next thing is we need IC and also we need IB. Here we have this one. We can apply KVL here in order to find out IB. This is IB. And if we apply KVL here, this is going to be what? KVL minus 5 plus 10K times IB plus 0.8 should give 0. 0.8 minus 5, that's going to give us 4.2, negative 4.2. If I move this one to the other side, that's going to be positive 4.2. So IB is going to be 4.2. Since we have 10K, we just divide 10K, and that's going to give us 0.42 milliampere. Now we have IB and IC. We can find out beta minimum. Therefore beta minimum is going to be equal to IC divided by IB. IC is 7.8 milliampere divided by IB, that is 0.42 milliampere. If we divide these two, that's going to give us 18.57. okay, now we found out beta minimum is equal to 18.57. that is less than 100, I mean less than 100, because beta is given 100. So we know that this is less than 18.57. This is satisfying the saturation condition, because the condition for saturation is beta has to be greater than beta minimum. Since it's greater than beta is greater than beta minimum, this is in saturation. Okay, that's the final answer, and that's how we do this kind of problems. I hope this helps. Thanks for watching.